Welcome to the first video of Module 2 where we're working with actual graphs. So in this video we just want to go over the objectives and the literature we're using here and the origins of graph theory, where this whole thing and field is coming from. So giving you a little bit theoretical background on where we're coming from. So the video we're watching is exactly the objective literature and origins of graph theory video here, which is the first video outlined for this module. The next video will be on basic terminology in graph theory that we will use throughout the rest of this class. And we will talk a little bit about graph properties in the third video, where you have to keep in mind specific aspects like, oh, this happens, I've seen that before, just so you're familiar with things and can recognize them again. We talk also about ideal graph types, not in the sense of, oh, this is what we want to achieve, but these are specific basic graph types that you will encounter in real life quite often. We have to talk really depth on storing graphs in matrices, because up to that point we will only show you visible graphs, and you have to store the picture somehow in a mathematical perspective so that you can actually do math with that. And finally, you can also store graphs as lists, something we will also talk about in a minute, or in another video actually. The origin of graph theory goes back to Leonhard Euler. In the city of Königsberg, he said there are 7 bridges connecting those 4 land masses. And his idea was, can we find a mathematical way to prove or disprove that we can cross every bridge once and exactly once? So can you get from the point where you are back to the point where you are by crossing every bridge once without going back one of the bridges double? So that was the problem on hand, and he has shown mathematically that it's not possible to exactly do that. It's a quite long proof, but this is the origin. And what has he done to get this all into a mathematical perspective? So he subtracted from this problem the 7 bridges of Königsberg and put them in a mathematical context. So I throw you some words at here. In the next video, I will explain you the words and what they actually mean. But so here you actually hear them for the first time. So the land masses that he was talking about, those different parts of the city of Königsberg divided by the river, became nodes. Sometimes you will also see the word vertex, something we will not use in this class, but we will stick with the word of nodes. The bridges became edges, and overall the representation became the graph. So the underlying reality is the network. And this is something we will stretch through this class and through the videos. When we talk about network theory, it's actually kind of a misleading title, I would say, because we're actually talking about graph theory, where graph is just the representation of reality. So in economics, you're familiar with models, and you know how little they sometimes have in common with reality because they abstract from reality. Similar is here with the graph, which is the representation of the underlying network. It's simplified, it's basics, and we have this representation of the 7 bridges of Königsberg problem here on the left, which is nothing else than any kind of a 7 bridges problem, which is again nothing else than having those 4 nodes and those 7 edges connecting those nodes. Ja. Habe ich